Hello guys, welcome to Learning with Lai. This is a continuation series video on indices. In this video, I would complete the laws of indices, and the previous video I treated 4 laws of indices. So I would be treating the product of indices and fractional indices. So for the next law, which is a raised to power of m close bracket is equals to, so this is the product of indices, a raised to power of m times m, so this is product of indices. And if we have examples on this, we have r, let's take for instance, we have r raised to power of 2 close bracket 3, so this is going to be r raised to power of 2, and this will be 2 multiplied by 3, and our answer will be r raised to power of 6. You can also have another example whereby we have 3 raised to power of minus 2 raised to power of minus 2 again, and this will be 3 raised to power of minus 2 multiplied by minus 2. Our final answer is going to be 3 raised, because minus times minus is plus, or when you have like signs, it's going to give you a positive sign, or when you have plus and plus, it's always going to give you positive. So this will be 3 raised to power of 4, and you can simplify this further, and your answer is going to be 81. We also have h raised to power of 4, and we have raised to power of minus 5, and this will be h raised to power of 4 multiplied by minus 5, and plus times minus, because they are unlike sign, is always going to be negative. That will be h raised to power of minus 20. So, and you can simplify this further using the law of indices. H raised to power of 20, 1 over h raised to power of 20. So further examples on product of indices, let's take for instance whereby we have something like this. We have minus 5 d raised to power of 3 all into bracket 2. So to solve this will now be, writing this in terms of algebra, this will be minus 5 multiplied by d raised to power of 3 raised to power of 2, and I can simplify this further and write it as minus 5 raised to power of, because we have 1 here, that will be 1 multiplied by 2 times d raised to power of 3 multiplied by 2, and our final answer, this will be minus 5 raised to power of 2 multiplied by d raised to power of 6, and minus 5 raised to power of 2, that will be minus 5 multiplied by minus 5 times d raised to power of 6, and this will be minus times minus, that will be plus, that will be 25 d raised to power of 6. Or we can solve it another way, whereby we have minus 5 d raised to power of 3 all raised to power of 2, and this will be minus 5 d raised to power of 3 multiplying itself 2 times, minus 5 d raised to power of 3, and we can separate this in terms of algebra. We write it out, this will be minus 5 d raised to power of 3 multiplied by minus 5 times d raised to power of 3, and this will be minus 5 collecting like terms times minus 5 times d raised to power of 3 times d raised to power of 3, and you can do the law of odd indices, and this will be minus and minus plus, and this will be 25, and this will be d raised to power of 3 plus d raised plus 3, because this is the multiplication law. Our final answer will be 25 d raised to power of 6. So we can see, using either of the two methods, we're still going to have the same answer. So I can also solve similar examples on that on a newer page. Let's take for instance, we have this minus 7 into bracket j squared raised to power of 4. Simply we can have this as minus 7 because it's not being affected by the power, is outside the bracket. So this will be g raised to power of 2 times 4, and this will give us minus 7 g raised to power of 8. Or we can solve it at minus 7 into g raised to power of 2 raised to power of 4, and this will be g raised to power of 2 in 4 places. I'll still have minus 7, this will be g raised to power of 2 multiplied by g raised to the power of 2, g raised to the power of 2, and g raised to the power of 2. And using the multiplication law of indices, so that will be addition of all the powers, and now since the base is the same, they are all the same, so we have g raised to the power of 8. 2 plus 2 plus 2 plus 2, that will be 8. So we still have the same answer. Another example on this, if we have minus 3 a squared all raised to the power of 3, and if we are to solve this, we can solve it as minus 3 times a raised to the power of 2, and this is going to be equals to minus 3, because we have 1 multiplied by 3 times a raised to the power of 2 multiplied by 3, and this will be minus 3. 1 times 3, that will be 3, and a raised to the power of 6, and this will be minus 3 multiplying itself in 3 places times a raised to the power of 6, and this will be minus and minus plus times another minus, that will be minus, so that will be minus, and 3 times 3 times 3, that will be 27, or 3 raised to the power of 3 times, no need to write times, this will be a raised to the power of 6. Or you can solve it the other way, whereby we have minus 3 a squared raised to the power of 3, and we'll do that in 3 places, raising everything in the bracket into 3 places. That will be minus 3a squared multiplied by minus 3a squared multiplied by minus 3a squared, and you can arrange this in terms of like terms. Minus 3 times minus 3 times minus 3 multiplied by a squared times a squared times a squared, and this will still give us the same thing similarly above, minus 27. Doing this, the law of indices, 2 plus 2 plus 2, and this will be minus 27 a raised to the power of 6. So doing it in different ways but still obeying the laws of indices, we're still going to get the same answer. And if you note, a negative number raised to an odd power will result to a negative answer. If you look at this, all of this is a negative term, all raised to the power of an odd number. 3 is an odd number, 5, 7, and it goes on like that. It's going to give us, our final answer is going to give us a negative number. But here now, when we raise this a positive number raised to an even number, the answer we got here was a positive number, but because the term outside the bracket is negative, that's why it's making the answer to be a negative number. Likewise, the first example here that we did, if you see it, all of this is raised to an even number, and we have a negative term here. Our final answer is positive, so we need to take note of that. So now let's go to fractional indices. Fractional indices, I'm going to write out the laws of fractional indices, and I did that in the first video, and I'll just rewrite them here. A raised to the power of m over n, this will be 1 over a all raised to the power of m over n. We also have a raised to the power of m over n, and this will now be square root of the root of n of a all raised to the power of m, and the final one, this is a over b raised to the power of a negative fraction, and this will be removing the negative power there, this will be b over a all raised to the power of m over n. And we're going to solve some example. All we need to do is to memorize these laws, and I have some examples to give better understanding. Let's take for instance where we have 8. Let me use another pen. Let's say we have 8. Let me clean this off. We have 8 raised to the power of minus 2 over 3, and this will be written as, using this first law here, this will be 1 over 8 all raised to power of 2 over 3. And solving this further using the second law, this will be the cube root, because the denominator always comes down, the numerator always stays up. So that's the idea. 1 over 8 all raised to power of 2. And solving this will be, I can share the root between the fraction, and this will be cube root of 1 and the cube root of 8. And the final answer, all will be raised to power of 2, and that will be 1 over 2 all raised to power of 2. And I can share the power because it is a fraction. This will be 1 squared over 2 squared, and this will be 1 over 4. So that's the answer. We've simplified this. So another similar example, if I do that still on fractional indices, whereby we have 16 over 81 all raised to power of minus 3 over 4. And solving this, I have to remove the negative power, and this will become 81 over 64 all raised to power of 3 over 4. Now using the second fractional indices, and I involve the square root, so this will now be the fourth root of 81 over 64 all raised to power of 3. The numerator always stays up, the denominator goes down to become the power on top. Sorry, this should have been 16, not 64. So we have 16 and we have 16 here. So excuse me. So the fourth root of, so I can share that, I'll just do that. The fourth root of, I can have this, the fourth root of 81 over the fourth root of 16 all raised to power of 3, and this will result to 3 over 2, and I'll cube the answer, so that will be 3 raised to power of 3 and 2 raised to power of 3, and the final answer will be 27 over 8. So but most cases when you do the root of any number that is maybe the root of any even number, maybe 4, 2, 6, the answers you have are always two answers, because you can either have a positive or a negative answer. So like here now, if you have minus 3 raised to power of okay, this will be minus 3 raised to power of 4, it will give us 81, and minus 2 raised to power of 4, it will give us 16. Same as 2 raised to power of 4 is also going to give us 16. So that's why anytime you do the root of any number that is having maybe an even number, maybe the fourth root, the sixth root, the square root, which is always 2 here, or the eighth root, we're always going to have two answers. So more examples on fractional indices, whereby we have something like this: 32 raised to power of 1 over 5, and I can write this as, following that second law, this will be 32, the fifth root of 32 all raised to power of 1, and this will now be, the fifth root of 32 is going to be 2 all raised to power of 1, and that will be 2. Another example again, whereby we have 27 raised to power of 2 over 3, and we can solve this. This will be the denominator always comes down. This will be 27 cube root of 27 all raised to power of 2, and cube root of 27 is going to be 3 all raised to power of 2 rather, and this will be equals to 9. So now let us now look at another example here, whereby we have a mixed fraction rather, and also raised to a mixed fraction. We have let me use another pen. We have 2 whole number 1 over 4 raised to power of 1 whole number 1 over 2. All we need to do is to change it to improper fraction by simplifying, and this will give us, when we change the inner bracket, we have 9 over 2, and this will be 3 over 2. And this will be obeying the second law. We will now have the square root of 9 over 2 all raised to power of 3, and this will be, I'm sorry, this is 9 over 4 rather, 9 over 4, and this will be 3 over 2 all raised to power of 3, and our final answer will be 27 over 8. And we can also simplify it further and still have 3 whole number 3 over 8. So sometimes, since if you remember what I said, when we have an even root, we always have a plus or minus. So most times it might not be there in some textbook, but some textbook might put it there. So I'm actually omitting it, but you could have a plus or minus if you have an even root, maybe fourth root, square root, sixth root, eighth root, and goes on like that. So more examples on fractional indices on another page. Let us now take, for instance, whereby we're giving decimals, something like this. We have 0.125 all raised to power of minus 1 over 3. So the idea for us here now is to change this decimal to fraction, and by doing that we will have 125. We change the decimal, this dot to 1. There are many digits after the decimals. We have 3, so that will give us 3 zeros all raised to power of minus 1 over 3. And solving this further, obeying the laws of indices, so this will be 1000 over 125 all raised to power of 1 over 3. Changing this negative power to positive, and this will now be the cube root of 1000 over 125, and excuse me, this will be 10 over 5. Our final answer here will be 2. So because you can reduce this to the lowest term, or even from this point here now, you can even divide, and when we divide through, we will see that 5 can go in both of them here. If we divide this, we have the cube root of 1000 over 125. If we divide this, 5 can go here, 200 over 25. 5 can still divide here, excuse me, so that will be 40 over 5, and 5 can still divide, and this will be 8. Cube root of, and cube root of 8 is still going to be 2. So we can solve it either way, so by simplifying. But if we're going to simplify, we have to make sure that we either have a cube number or a square number. So you can divide the fraction if the resulting answer will be a square number or a cube number. A square numbers are like 1, 4, 9, 16, and so on like that. And we also have cube numbers, e.g. like these are, let me write a square numbers, and cube numbers also, maybe like 1, 8, 27, and so on like that. So these are cube numbers. So the last example I'll solve on involving fractional indices. Let's take for instance we have something like this: the fourth root of 16 a raised to the power of minus 12. So how do you go about this? So I can share this, I can rewrite this first as 16 times a raised to the power of minus 12, and this is going to be equal to, I can now share the cube root. This will now be 16 times over a raised to the power of minus 12. Excuse me. And simplifying this further, this one will be 2 multiplied by, so I'm going to do this like going back the reverse way, and this will be a raised to the power of minus 12 multiplied by 1 over 4, because this cube root is the same thing as 1 raised to the power of 4, and I'll simplify this, and this will give me minus 3. So my final answer from here will be 2 multiplied by a raised to the power of minus 3, which I can also write as 2 over 2 over a raised to the power of 3. So you can see there you have it, guys, product of indices and fractional indices. So if you found this video educative and instructive, please click the like button and subscribe button. But before that, I have some questions here to test your understanding, so you can go over them. There are 12 questions and the answer page, so you try and solve them, pause the video, and when you're through, few minutes later the answer will come up, and this is the answer page. So thanks for watching, and please subscribe. Thank you.